This is section 7.2, division properties of exponents. Now, if you didn't write down these simplifying rules from the last video, make sure you write them down now. Again, we can't have negative exponents, and we'll talk about those in this section. We can't have the same base appear more than once in product or quotient. We'll be working on the quotient part today. Now, powers with powers, no products or quotients are raised to powers. Again, we'll talk about that quotient part today. And then make sure in quotient you don't have any coefficients with common factors. Alright, so our first rule of the day is the quotient of powers property. So let's try and figure out that rule. So we have 2 to the 5th over 2 to the 3rd. So let's think about that. We have 2 to the 5th would be 5 2's in a row, divided by 3 2's in a row. So there's 2's in the numerator and denominator, they'll cancel each other out, and we're left with 2 2's, or 2 to the 2nd. So if we look at this, 2 to the 5th divided by 2 to the 3rd, and I got 2 to the 2nd, what did I do with my exponents? Well, I subtracted them. So I'd have a to the m minus n is my rule. So when we are multiplying, we added, and now when we're dividing, we are subtracting. So let's do a couple of examples. We have g to the 3rd, h to the 5th over g h to the 2nd. So you're thinking of the g parts as 1, and that's g to the 1st since there's no exponent written. And then h to the 5th over h squared. So you're technically grouping each of them. You can do this without that step if you are familiar. So subtracting g to the 3rd, g to the 1st, we get g to the 2nd, and then h to the 3rd. Alright, the next example, we have the k's, the m's, and the p's. So k 7 minus 3 is 4, so k to the 4th, 10 minus 3 is 7, so we have m to the 7. And for p's, they're both to the 1st power, so we have nothing left because they cancel each other out. So I don't have to write p's. This would also be p to the 0, which equals 1, and we'll talk about that on another slide. Our second rule is the power of a quotient property. So if you have a quotient, you can do the exponent to every term inside. So let's see how that works. So 3/4 to the 3rd would be 3/4 3 times. So my numerator has 3 3's, or 3 to the 3rd, and my denominator has 3 4's, or 4 to the 3rd. So I can do that exponent to the numerator and the denominator. So my rule, if I have a over b to the m, is a to the m over b to the m. And just make sure I distribute that exponent to everything. So let's try a couple of examples of that. So my exponent is 2. I need to make sure it gets to every term. So I have 3 to the 2nd, p to the 3rd to the 2nd, and 7 to the 2nd. So I need to do each of those. So 3 to the 2nd we know is 9. P to the 3rd to the 2nd, 2 exponents again, we multiply those. We get 6. And 7 to the 2nd is 49. Now if 9 over 49 are reduced, you would make sure you did that. So let's look at the second example. We need to do this exponent of 3 to every term. So we're doing 4 to the 3rd power, x to the 3rd to the 3rd power, 5 to the 3rd power, y to the 4th to the 3rd power. So 4 to the 3rd is 64. X to the exponent with an exponent multiplies, so 3 times 3 is 9. 5 to the 3rd power is 125. And y, 4 times 3 gives me my 12. Again, if you can reduce, make sure you do so. So I said we would talk about the zero exponent property. Any non-zero number, so again, non-zero, raised to the 0 power is equal to 1. So our rule for 0 exponents, a to the 0 equals 1. And we saw why that ends up happening, like when we had p to the 1st over p to the 1st. Well, they divide out, they cancel each other out, and that equals 1. Just like 5 divided by 5 equals 1. p divided by p equals 1. So this p to the first divided by p to the first, if we use our exponent rules, we'd subtract and get p to the 0. And we already said that's 1, so that's why that works. So you could have something ridiculous, like 2x y to the third over 4z. If it's all raised to the 0, it's the easiest problem. It's just going to be 1. So negative exponents is where things start to get a little tricky, but they're very important. So I'm going to show you two ways we could do the c to the second over c to the fifth. We could use our exponent rule that we already know and subtract. 2 minus 5 is negative 3. We could also write it out the long way and kind of see how that works. So we have 2 c's on top and 5 c's in the denominator. So if you look at that, the 2 on the top will cancel out with 2 on the bottom, so we have 3 left in the denominator. So that tells me, I just did this 2 different ways, that c to the negative third is the same thing as 1 over c to the third. So that kind of gives me my rule that I need. I have a negative exponent, so a to the negative n. I can put that in the denominator and it'll be a positive exponent. And vice versa, if my exponent was negative in the denominator, I could put that in the numerator and I'd end up with a positive exponent. So a negative exponent is kind of just like, oops, I'm on the wrong side of the fraction bar. Let's move me to the other side so that I am positive. So let's look at a couple of examples. So here I have n to the negative fifth, p to the fourth, and r to the negative second. So there isn't any variables I can combine, but remember, we don't want negative exponents. So n is in the numerator, and it's negative, and r is in the denominator, and it's negative. So remember I said negative exponents, oops, I'm on the wrong side, let's move them. So n is going to get moved to the denominator and become a positive 5, and r will be moved up to the numerator and become a positive 2. The p gets to stay where it was at since it was already positive, and now I am simplified because I have no negative exponents left. Alright, let's look at the next one. I have 5 over negative 20. That's one part I need to simplify. I have r to the negative third over r squared. I have t to the fourth over t to the seventh. And I have 1 over u to the negative fifth. So let's simplify each grouping first, and then we'll worry about the negative exponents. So 5 over negative 20, well, that reduces to 1 over negative 4. And then we have these r's and we need to subtract, so we have negative 3 minus 2. We get negative 5 exponent. 4 minus 7 for the t's gives me negative 3 exponent. And the u's, there was only one group, so I'm going to leave that in the denominator for the moment. However, all of my variables have negative exponents, so the r needs to go to the denominator and with the t also, and the u needs to come up to the numerator. Oops, and that would be positive 5. However, the 1 and the negative 4, those can stay, and you don't actually have to write the 1 if you don't want. The negative 4 did not move because it doesn't have a negative exponent. It has a negative coefficient, but the exponent's not negative. So the only time you're flipping is when you have a negative exponent. It doesn't matter if the number's negative, the coefficient, and if the exponent's negative. Alright, let's look at this next one. Now there's about 3 different ways that you could start this problem. You could simplify inside the parentheses first, and then do this negative exponent. You could do the negative exponent in first. You could flip things around so they weren't negative exponents. So there's a lot of ways you can go about doing this. I am going to simplify inside first so that I have less things to worry about. So I have negative 3 over 6. That's the same as negative 1/2. The x's I need to subtract. So I got negative 6 minus a negative 2. That makes it a plus 2. So negative 6 plus 2 is x to the negative 4th. Same with the y's, I need to subtract. So this is a 1 down here, so negative 1 minus 1, that will be y to the negative 2. And then z's negative 2 minus a negative 5 makes it plus 5. So I have z to the third. Still all raised to the negative 2 exponent. So I did the inside first, so I had less variables to worry about. Now, I need to do this exponent in here to everything inside my parentheses. So, I need to do the negative 1 to the negative 2. I need to do the x to the negative 4th to the negative 2, y to the negative 2nd to the negative 2, z to the 3rd to the negative 2, and the 2 to the negative 2. So you don't have to write out every single one of those. You can do those mentally. I'm just showing you have to do that to everything. So, I need to simplify these. These two are going to have to get switched around since they both have a negative exponent. So I'd end up with 2 to the 2nd over 1, or a negative 1 to the 2nd. X, that would be x to the 8th because we multiply. That would be y to the 4th since we multiply and 2 negatives make a positive. And that would be z to the negative 6. And z is still in the wrong spot, so I'm going to do one more step. Negative, or 2 to the 2nd is 4, so x gets to stay and y gets to stay. Negative 1 to the 2nd is just 1, so I'm not going to write that. But the z needs to go down in the denominator, so that's a positive exponent. And there's our final answer.